Привет, everyone, and spasiba for being here. You could have been in any of the other two amazing talks, but you decided to be here to check your email. So thank you very much for that. Thank you for being in this room and being at this talk. It's very late in the afternoon. This has been a very busy day, so I appreciate everyone is getting very, very tired, and it's going to be tricky to keep the concentration for the next 40 minutes. Also considering this is an English talk spoken by an Italian, so that's really messy. I know. So I decided to turn this talk into a small bug hunt, because I understand you guys like it. So here is how it works. In this talk, there are 3 bugs or 3 errors, mistakes. If you can find them, please resist the urge of raising your hands and shouting that to the world, and come find me afterwards in the talk. If you find 1, you get a handshake. If you find 2, you get eternal glory and a pat on the back. If you find all of 3, then you get some Swiss chocolate. So let's hope that not all of you find 3, because that's going to be a problem otherwise. So with this in mind, I guess let's get started. I'll try to make this worth your while, and let's get started. So who's this guy on stage? My name is Claudio Criscione. In case you didn't guess so far, I am Italian, as proven by the pictures on the side of the slide. My background is in security, really, so I'm kind of the oddball talk in this conference. I have about 10 years between penetration testing and vulnerability assessment and everything that is connected to security. And then about 6 years ago, I moved to Switzerland because I was hired by Google. Might have heard of us. We're kind of the American Yandex. And we do lots of stuff. In Switzerland, I've been driving the security automation team, which is a team that is tasked with scaling security testing at Google. That is very tricky, and hopefully I'll manage to convey that to you during this talk. Now keep in mind, I'm fundamentally a web security guy, so some of my terminology when it comes to testing might be slightly off. Please do cut me some slack there. And also, most of the examples in this talk will be within the web realm. I think the generalities and the general points that I make apply everywhere. The examples will be in the web space. So before we get started, how many of you have security either in their job title or directly within your job scope? Can you raise your hand, please? Okay, so not many of you. Let's hope that we can change that by the end of this talk. So let's get started. What is this talk about? This talk is a first-hand account, is a story of the things that I found out during these 6 years when I have been trying to do security testing at scale. Some of the things that worked in that context, some of the things that didn't work, and for once I can actually talk about failures, which is refreshing for a change. I don't claim to have any silver bullet, really. Some of the stuff that we tried and worked might not work in your environment, and vice versa. If you do try some of these, please let me know. I would be curious to know how that goes. So what is the problem that we try to solve? Well, the main question I was asked pretty much when I was hired was, how do we solve security at a scale? That's a very vague question. I have no idea was my first answer. So I started thinking, how do you solve security at the small scale, which is usually much easier? And in the vast majority of cases, the answer for security is to get someone that is deeply expert in the security field, that knows everything. Is this kind of mythical figure that you can just throw at the project and it comes out bathed in bugs and security issues, and you just need to fix them and everything will be amazing. Now this figure, I call it the Hollywood hacker, and you can tell it's a hacker because of the hoodie. This person is amazing. He can solve literally any security problem that you throw at him. He can sit with the project, sit with the developers, and they will come up on the other side victorious, and you will have no security issues whatsoever in your project. Now, this is the standard answer, right? You might find people that are not quite the Hollywood level, so maybe they actually need to do work to make security happen. They don't just impose their hand on machines and firewalls blow up. But in the essence, what I observe in the vast majority of cases of companies that I've interacted with is they tend to have this security team that does their mambo-jumbo somewhere in a room, and that's it. Well, this kind of works at a small scale. When you operate at the scale, okay, that's funny. This decided to stop working, doesn't matter. When you operate at the scale that we do, things get a lot trickier. So Google has about 30,000 engineers, more than that. They submit about 30,000 changes per day. Our code base is somehow large. It's about 2 billion lines of codes. So yeah, that's pretty big. And 86 terabytes. I should also add that about 50% of the code base changes every month. So it's kind of tricky to keep up with that. And any of those changes might introduce security bugs. So now, the real problem you have is how many Hollywood hackers do you need to solve this problem? Yeah, fair enough. Okay, you got me there. Sure. If it was to be a really Hollywood hacker, I would even argue, to be honest, that he wouldn't have enough time to impose his hand on all the systems within one day. But the reality is you need a lot of them. And one, you can't really hire them because budget. Because your organization is going to grow, you can't just keep hiring security people. Right? This strategy only works for a bit. And the second problem is there aren't so many security people. Even if you wanted to hire them, hiring security people, it turns out is very hard. Why? Because the people you're looking for, these Hollywood hackers, are extremely good. They have a very long, very large amount of know-how, and so there aren't so many people with that set of skills. So, can't really solve this problem by throwing bodies at it. We need to come up with different solutions. This is pretty much the scenario that I was given when I joined the company. Of course, you are in testing, so you know what the solution to this sort of problem is. Being in security makes some things actually, for whatever reason, slightly more complex. The standard answer is to automate, right? You can't just throw people at a problem, start throwing machines at it, and surely it will go away. Now, your automation strategy when it comes to security needs to be made of a number of components. It starts with more secure libraries, it starts with more secure APIs, compilers, yada yada. There is a huge number of things that you should be doing. But at some point, as we all know, all these measures that you have put in place to prevent security bugs from happening will fail, and you will be left with just testing to identify the bugs that slip through all the other checks. And this is what we'll be talking about, security testing. So the last chain of what should really be a large security strategy. Now, before we go forth, whenever I talk about security testing at a scale, the first thing that I get asked is, which vendors do you recommend? Which tools would you deploy? What exactly should I buy? Well, I would love to be able to give you an answer to that. The reality is that when you work at our scale, security tools don't quite cut it. Most of the commercially available ones, at least. Maybe some works. The tests that we have done are not very encouraging. But in practice, I will be, for the rest of this talk, largely discounting what is indeed a very large industry. Why? Because I think they got some very core things wrong, at least for the scale that we operate at. And that's what we set up trying to fix. So a lot of the tools that I will be describing here are internal, and I will be focusing on this logic and the strategy more than how it's actually coded. Most of them are surprisingly trivial to code. There is no black magic in there, actually. So first big reason why I will not be talking about security testing tools that you can find out there in the market is this one. Most of these tools are written by security people for security people. And if you remember the scale issue, you're not going to have enough security people. Now, you should be thinking, why on earth is this a problem? I mean, sure, these are engineers. I'm sure they have their own kind of competence, but I can probably pick it up and learn it. Well, this is about half of the help page of SigmaMap, which is one of those security tools. It's an amazing tool, not really for detection, it's for exploitation. It doesn't really matter. The thing is, you can't really expect a test engineer or the developer to sit down and read through that stuff. That doesn't happen, not anywhere in the universe. This is the sort of stuff you as a security professional can spend days digging into and figuring out and using on one specific exploit, because that's all you need. And now you have one attack, yay, and you have just the other million to find out. So, security tools, not going to talk that much about. So, what am I going to talk about? Well, I have been told that Russian audiences really appreciate examples and in-depth technical analysis, so rather than boring you with all the management stuff that is behind it, how about we go to an example? So how many of you are familiar with the security bug commonly known as mixed content? Can we do a show of hands? No one has ever heard of mixed content? Thank you very much. I'll pay you a beer afterwards or a beverage of your choice. So mixed content is an interesting one because it's trivial, it's everywhere, and it takes a lot of effort to fix and identify. Let me walk you through it. So mixed content manifests itself when you are in an SSL context. So we are within an HTTPS channel. I'm sure you're familiar with it. It's an encrypted channel. It's when you fetch your web pages and you have that green lock on top. That means the communication is encrypted. No attacker can tamper with the content, okay? Pretty easy. Now, what happens very often is that your ops or your engineers set up that nice SSL website, figure out all the certificate management, set everything up, and it's amazing, and then a developer does this. Right? That is what's called mixed content usually. Right? That's common parlance for mixed content. It's an active component of the page, in this case a script, that is loaded over HTTP. That is really bad because it means that you're foregoing entirely the protection afforded by SSL. Why? Because if an attacker, a man-in-the-middle attacker, can tamper with the content of that file, which is not encrypted, so that's the very attack model that SSL is meant to protect you against, they can just mess with the page in any way they want. Because now they can execute JavaScript code. Now, the reason why you might not be familiar with this is that all modern browsers, when confronted with this very situation, so SSL context, HTTP content inside, do the following. They just stop you. You get an error, and it tells you, look, there is mixed content in this page. There is no way on earth I'm going to load this JS. Sorry about it. So you might have seen this happening because people were complaining, a classic, that your ads library, the library that generates the ads in your website, was not being loaded. It's not functional breakage. I mean, usually functional breakages you notice very fast, but there might be subtle breakages. Now, that situation with the content being blocked on the network is very recent. It didn't happen until, I think, 4 years ago, something like that, 3 years. So relatively recent compared to the history of the bug. Why? Well, because mixed content was everywhere, and it was too risky for browsers to stop it. So instead, you got this nice yellow icon at the top that told you, yeah, this page is kinda secure, but not quite. Which wasn't, to be honest, completely transparent, because the page was completely broken. So, when I get hired, we have this problem. We have mixed content everywhere. But now, you're looking at this bug, right? I mean, there is this script, source HTTP. How hard can it be to find that in your code base? In fact, that very example is fairly simple. You have your code base, you have HTML pages or templates or whatever else have you. You just grab through the pages, HTTP, found, shouldn't be there, replaced with HTTPS, or better use protocol relative addresses, but doesn't really matter. Now, you can do that, very effective. When you get screwed up, is when you have this. So when you have a JavaScript component that loads another JavaScript file and builds the URL of that JavaScript file dynamically, the vast majority of ads libraries do that. Is this trickier to find now? It's getting trickier. You can still probably do it, because what you can do is you can take the template, show it into a headless browser, render the page, and identify the components that have HTTP URLs. Doable. Tricky, but doable. When it really, really gets fucked up is here. When you have an interaction that triggers a JavaScript event, which in turn generates a mixed content event. That means that in order to identify this bug, you need to know exactly where to click. And if that is triggered by a menu event that is 4 levels nested, good luck finding it. So that's the type of problems we had. To make things even worse, a lot worse, we had just a tiny bit of pages to take care of. Now that number is clearly off, but the number is indeed very, very large. So we had this problem, right? We need to be able to identify a bug that is pervasive. It's very hard to reproduce and trigger. It's tricky to explain to developers because it's not so easy to pass that information across. How do we do? So we started thinking, what we really need, some kind of automated procedure that is meant to be interacting with large portions of your application, right? Now you're testers. What is this stuff? What is this stuff? Oh, come on, don't let me down here. Well, that's pretty much end-to-end testing, right? I mean, if you think about web-based tests, this is what they are going to do, right? Your web-based tests are going to be automated procedures that interact with large portions of your web application, hopefully. And indeed, it turns out that there is this thing called Selenium that I'm certain you will be familiar with to one degree or the other. What is this? It's just a way to instrument a browser and have it programmatically interact with a web application, right? So what this thing does is it's a protocol and a testing framework. I won't spend too many words in this. I'm sure you're aware of this tool or can easily research it. The point is, development teams were already building the stuff that we needed. They were already building end-to-end web-based tests that would go through the web application and interact with all these nasty things, nested menus and what have you. We just had to find a way to reuse them. Well, first of all, we asked, how many are we going to have? Is that going to be worthwhile or are we wasting time? Turns out we do run quite a few tests, about 150 million per day. We have, I think, 13,000 plus projects that we do continuous integration for. So, even if a very small percentage of that is useful end-to-end web tests, we're probably going to be fine. So, how do we go about this? The core idea is we do have something that takes us around and gives us coverage of all these web applications, right? We visit the page, we surely can wait to see all the functions of the page being triggered, and we wait for mixed content. The core intuition here was to use a trick. Rather than messing with the test infrastructure, rather than instrumenting the browser, rather than opening up all the insides of the test frameworks, we realized that in essence, the way a WebDriver test works is very simple. There is a brain, which is the WebDriver code that the developers have actually written, or the test engineers have actually written, that drives around the browser. This browser does HTTP requests, gets HTTP responses with the web pages, interacts with the web page, right? So how about we just listen very carefully to the traffic, and we spot all those HTTP requests. All that is left to do is wait for the bugs to fall off. So we run our nice test against the SSL page, wait for HTTP requests to go through. Those are all mixed content that needs to be fixed. So that was the core intuition. And this is the simplest example. If you know deeply about the structure of mixed content bugs, you will surely be thinking about the corner cases that are not covered in this super simplified example, that they are all true. Ask me later if you want to know more. There are so many corner cases in this space, but you do get to cover 80% plus of the whole space, which is a lot when you consider the numbers we work with. Okay, simple enough. How do you do it? Well, in terms of code, this turned out to be surprisingly simple. We created a project. We called it Mango because it's juicy. I think that was the inside joke for whatever reason. And that's the HTTP proxy, whose only job is to log whenever an HTTP call is built. Then we take the proxy and we inject it within the profile of the WebDriver test. I'm sure slightly more recent, we're talking about 4 or 5 years ago now, this code. More recent versions of WebDriver are slightly different syntax, but it doesn't really matter. You're not changing the test in any way, you're just shoving a proxy in between. That's it. The proxy just lets all the requests through, to and from. That's about it. Then you run your nice test, and you're pretty much done. Okay, this is a trivial example. Let me give you a slightly more complicated one. So, given the responses before mixed content, I'm slightly pessimistic here, but let's give it a shot. How many of you are familiar with the concept of cross-site request forgery? Well, that's amazing. More people know about cross-site request forgery than mixed content. Okay, maybe it's just the naming here. Great, so I'll be very quick in going over what the bug is. And for those of you that know, please bear with me. Very long wall of text. What is cross-site request forgery? Cross-site request forgery is a very specific class of bugs that exploits the inherent trust built in the web platform. There is no idea of intent. How does it manifest itself? Well, an attacker from an evil website can forcefully generate a request on the user behalf on the target site, and the target site has no way to know if the user clicked somewhere of this request has been generated by, say, an auto-submitting form. The cookies, the authentication cookies or the authentication items will just be included in the request and it will go through. Now, this is exceedingly confusing and meant to be so let's go through an example. Let's say that you want to run an election. And you're running the best letter of 2019 election, right? Now, this site is very, very simple. There is a vote button. You click on the vote, click, post request goes through, vote, best letter, the number increases. Now, if you were to rig the election, not that any of you would want to, but if you were to, the way an attacker would go about this is by creating a totally unrelated page and just have inside that page a JavaScript component that performs the same post. Post goes through, the website on the other side has no way to know if the user clicked or something else happened, vote accepted, election rigged. So how do we fix this? Very simple. There are actually a number of ways, but we're going to simplify here and just say that the standard way to do this is include a token, so a secret that is shared between the target page and the server. So the front end and the back end. The attacker has no way to know the value of that token, and so there is no way he can exploit that vulnerability. Okay? So the vulnerability is not there effectively. That's XSRF. Now, once again, if you know what I'm thinking, we have these WebDriver tests, these end-to-end based tests. Actually, you know what? How many of you do have end-to-end web-based tests in your organization? Can we do a quick show of hands? It's not as many as I would have hoped, but it is a fairly common thing, at least at Google, right? There is no way you can ship a product without integration testing. It just doesn't happen. So, again, if we think about the example where you have this web test and you can passively intercept the traffic, there are a couple of very obvious ways to identify these XSRF bugs, right? Number one, just look for requests that don't have anything that looks like an XSRF token, right? There is nothing called token, it's probably bad, it's a post request, probably a bug. Or do a bit of entropy analysis to try to figure out what are the values that might be tokens. So maybe it's called foobar, but the value inside is so messy that it could also be a token. So basic heuristics, they work reasonably well, but they do have a few problems. First of all, you're going to miss tons of bugs. In security parlance, false negative is a situation where you should have had a bug and should have reported a bug, but you don't. Now clearly, if all that you're doing is looking at the protocol, at the traffic, you might see the token go through, but no one is checking on the other side. You don't really know, you have no way of knowing. In fact, this bug is so common that there is even a name for it. And this is before specific vulnerabilities started having logos and fancy names, right? So it was kind of a big deal if you had a name for a vulnerability. And it's generally called execution after redirect, which is just a way to indicate a piece of code. Now, I chose PHP, which is the best language in the world when you have to explain bugs. This is an example that you see very, very often in production. If the token is there, then set the response code to 403. So from the outside, this thing didn't work. Yeah, and then do something. So no return in there. That's a classic example of situation where the token is there. You even see the error code coming back, but actually the attack went through and did whatever it was supposed to do. So that's the first class of problems you run if you try to use this super naive approach. But even worse, you have false positives. So you have situations where the token was there, but it was called secret, and you didn't think about having secret in the value, and the entropy was not that high, so you flag it as a bug, but it's not actually a bug. Well, now, if you're not familiar with the sort of scale that we work with, you might think, what's so bad about it, right? I mean, could have been a bug, might as well report it, could be these bugs are devastating, right? If you have one of these bugs in a production service, think about a service that lets you send messages or do likes or similar things, right? It can be devastating that people can forge this request. So we should really be flagging them. Well, yes, but it's kind of a pet peeve of mine. False positives are the one reason your automated security testing strategy will crash and burn if you don't handle them correctly. Why? I think there are three main reasons. There are many, but there are three main. One, false positives are actively damaging. They're not just innocuous, because it's not like you report a bug and then it just goes away by itself if it's not true. People have to spend time looking at it, right? And what's worse, it's security told me that there is a security bug. Oh my God! And people spend time into it. You can't afford it. Why? Well, not only you're wasting time, but you're also eroding the trust that people have in you as a security guy that is yelling at people for fixing bugs, and the tools that you use. I can tell you, in my experience, if you go to a team with one false positive, they'll be lenient. If you go to a team with a second false positive, they'll be slightly pissed. And if you try to go to them with the third false positive, the door will be closed. They will just not listen. So losing that trust is devastating for any security testing strategy. Finally, somehow related, you can't automate. If you have false positives, there is no way you can block release. There is no way you can do automation, for instance, rollback whenever a bug is found. You can't do anything, right? Because no one will be happy to see one of those things happening on a false positive. So please, please, please keep it in mind. No false positive ever if you go through a security testing strategy. And this simple mantra will devastate the vast majority of tools that you can deploy. Because they brag about the fact that they have a 1% false positive rate or less than 1% false positive rate. Now do the math. We do 150 million test runs per day. How much is 1%? It's just not going to work. So let's go back to the XSRF case, right? Which is slightly boring, but an interesting example of how deep you have to go if you want to have any effectiveness whatsoever, right? Keep in mind, up to this point, we have done nothing. We have achieved nothing. Because the systems that we are describing here will in practice not be used. Too many false positives, false negatives, clunky, not gonna happen. So, recommendation, always focus on false positive first, even if that means missing real bugs. That's fine. We can live with that. No testing strategy can find all the bugs. This is not gonna happen. You can find many, and you can get them fixed, which is a lot more important. Now, in the XSRF case, the way we translated that was being extremely liberal in the way we identify tokens. Pretty much everything is a token. It's a token party. Just let them through. Now, clearly, what happens is that you have tons of false negatives and you find no more bugs whatsoever. So you have to strike a balance. So next step, how about every time we see a request that has a token, we drop it and replay the request and see what happens. Still kind of nice, but it complains about irrelevant things. For instance, situations where the post does nothing at all. It misses real bugs, like the cases I told you before, where the server ignores the token. So, yeah, somehow better, but not quite there. Now, a slightly better approach is to use mutation testing, which is something you surely are familiar with. I had to learn. Actually, I described the technique, and one of the fellow guys in the program committee looked at me and said, but this is mutation testing. Why don't you call it that? I said, okay, you're right. What we do here is, instead of letting the request through, we stop it, drop the token with a certain probability, and then let it through. We do that only once per test, and clearly that means one request per test gets modified. Now, if the test passes, then there is something wrong. Because it means that token, or what we thought was a token, was inconsequential. It means that either the server ignored it, or the values that it was setting was unfixed. So the rate of false positives with this sort of approach plummets really, really quickly. And it lets you use the logic that is built inside the test to identify bugs. Now, one thing that I said here that I just assumed was kind of easy and let it slip through is flag cases, flag the bugs. Now, it kind of seems like it's obvious once you find the bugs, how to get people to fix it. If you have 30,000 engineers, it's not like you can be sending emails to them, hey, please, I found this bug. That doesn't work. So you need to find a better way, and you need to automate that away. Again, communicating bugs at scale, very tricky. The default option that we have, which you can pretty much always do when you have a security testing tool, that's the default when you buy a vendor-provided thing, this is pretty much what happens, is to do out-of-band communication, right? Send this nice love letter to the developers, hey, ding, you got a bug. Now, the problem with this is that letter now needs to contain a hell of a lot of content, right? It needs to tell you at what CL, at what change list, at what point in the code the problem happened. It needs to collect all the information about the test run so that the developers can triage it properly, or the test team can triage it properly. You just need to add a lot of information. Now, this thing is super expensive, and it also comes with having to go to every single developer and ask, hey, did you remember to check that other dashboard that we built for you, which contains all the results? Not working. So, what do we do? Well, again, very simple solution, trivial if you are within the realm of testing, not so much if you're a poor security engineer like me. You integrate that within the test suite, right? So in the same way, before the test suite, we would set up the proxy. At the end of the test suite, or at the end of the individual test, you query the proxy, and you ask, hey, did you see anything wrong? If you did see anything wrong, then you failed the test. Now, what happens is that the reporting moves in line within the test suites. And it's no longer in some dashboard in a corner with a UI coded by security engineers that wants to, that every time you look at, you want to take your eyes out of your brain. No, 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 no. It's in your nice UI. It's a nice test dashboard. It comes with all the test log of that specific test run. So this is what we ended up implementing. Now clearly, we don't just have one test dashboard because this is Google and we never have one of anything. So we had, I don't know, 10 or so. But once you are inside the test suite, it doesn't really matter. It will be the testing framework job to deliver that result somewhere. So that's the direction we ended up going, and we liked it a lot. So takeaway, core point. Because so far I've been picturing this super rosy picture, and I'm gonna tell you all the stuff that doesn't work. What we did and the approach that we took is to reuse all the tests and the testing infrastructure that we had to find new types of bugs that happen to be security bugs. We focus on producing actionable, useful results, so not finding everything, but the stuff that we found, we try to make it matter. Okay, so what's the catch? This is all great in theory. This guy is telling me about how to achieve these amazing results, but is it really that good? Well, maybe. Let me start. First problem, which is really set. It turns out that test and prod are not the same thing. Who would have thought? And in practice, this matters a lot, because some of the security properties that we want to test are radically different between the test infrastructure and actual production. Two examples that are within the specific bugs that I described. There are many more. If you're running a test system, why would you take on you the burden of maintaining SSL certificates, crypto material, and all the things that you need to do SSL? Well, there could be a few reasons, like load testing that is reliable and maybe finding mixed content. But in practice, a lot of teams didn't want to do that. So they run their test environment over clear text and a production protected by SSL. So good luck finding mixed content now that everything runs over HTTP. Same thing for XSRF token. If you have no reason to have XSRF protection in a test system, it just makes things easier. So why would you? So what we ended up doing, just run it against prod. It's probably going to be fine. And well, it might sound like heresy to just take a test suite and run it against prod. But if you're Google and you're running something on the internet in production, if it's not you, I can guarantee there is someone else that is testing it anyway for you, and they might or might tell you about that. So might as well do it. So that was the first issue that we ran into. Second fun thing, do you know how you draw an owl? That's how you do it. So tests take horrible, horrible shortcuts. One example, we had this calendar application, end-to-end test. You go to the calendar, you create an event, you give all the details, press save, events created, click again, verify the details are there. Sounds reasonable. However, the developers felt that there was no need to actually test again the form when you edit the details, because that has been tested in unit testing in other places, so yeah, let's skip that. So what they did is they opened the browser, go to the calendar site, then do an RPC call, create the event somewhere else, and wait for it to pop up in the UI. And we looked at the test and wondered, why is not finding the mixed content in the edit box? It should, that's why. And we found all this sort of stuff pretty much all over the place. So it turns out developers and test engineers like to take shortcuts, really bad ones. Now, the previous one was a problem for us as the security team. This one is what really got the testing teams to hate us. What happens if you have a brittle test, a test that is very sensitive to small changes? It goes 2 seconds slower, test fail. Well, I would argue you have to fix the test, but not all test engineers agreed with me. And in practice, what happened once you throw a proxy in it, a Java proxy at it, written by security engineers. So you get where I'm going. What happens is that you increase the latency of the test, and sometimes you change the order of the requests. So what happened is that you have just turned a test that was brittle into one that is flaky. So sometimes it passes, sometimes it doesn't, and so on, right? So you just fabricated yourself a very nice Heisenbug. Not fun. The test engineers are not going to like it at all. So that's also something that we had to look into very, very carefully. And finally, this morning in the keynote was correctly called out that integration and infrastructure is great, but you have to maintain it. And if you have a very small team of security engineers that is maintaining this infrastructure, it gets out of hand really, really fast. So there was a lot of work. Every time we had to change the infrastructure changed it, we had to change the integration. We got pretty good at that. It got to a point where you would just run your test and then add -- with security, and we would do the security test for you. That was pretty nice, but there was a lot of work behind it. So, all in all, did it kind of work? Well, almost, I would say. We found a few bugs, which in our parlance is a few thousand critical bugs. That's quite a large amount of money, and we paid for them in the vulnerability reward program that we do, where we reward security researchers for telling us about security bugs. So I think it was effective, but everyone was getting kind of burnout of chasing all these issues that I described. So we realized, look, this strategy is nice, great idea, but we need to iterate on it, we need to do better. So what's the next step that we took? Well, we moved towards self-service approach. Everything that I described so far is about scaling the capabilities of a security team, right? Which is small and can achieve a lot thanks to the infrastructure and the test systems that the rest of the company has built. But to do more, you really need to be the spinach or spinach to your Popeye. So you don't need just to scale the security team's ability, you need to scale the ability of everyone else to do security, which is where we went. And there is an entire talk to be done about self-service. So I just want to give you 2 points that I found extremely important. What we did is we engaged with teams, and rather than just making this test happen without them even knowing, that's just bugs popping up, we partnered with them and tried to understand how we could provide them the tools to test themselves. 2 important things, 2 big challenges that we have found. 1, the need for simplicity, and 2, this absolute need for integration with the existing infrastructure. Example of simplicity. We figured out that it was absolutely unreasonable to go to a test engineer or developer and ask him, can you spend 3 days to set up this security test in your application? That doesn't happen. No one got the time for that. So we had to make things simple and streamlined, ideally under the attention span. Today, the test that I described before, you can set up in less than 3 minutes. That's the line that we set ourselves. If it takes more than that, there is a very high chance that it won't happen, sadly. Slightly longer when you get more complex projects, but not that much longer. Second problem, the results that you report need to be self-explanatory. If a developer or a test engineer needs to come to you as the security team, hey, can you please explain exactly what you mean with this stuff? Then your scale is gone. You can't handle all of that, right? So you need to make sure that whatever you deliver makes sense by itself and can stand by itself. This is something where the vast majority of security tools that I've seen does a horrible, horrible job. Think about the huge list that I showed you before. Second point, integration. Tools, security tools in particular, shouldn't be something that you just bolt on top and sit somewhere in a corner hoping that someone will use them. They need to be part of the pipeline. Now, what you're seeing is an example of how we integrated security scanning with one of our tools within our build and testing infrastructure. You might not be familiar with it, or you have no reason to be familiar with it after all, but our build system is called Bazel. It's an open source project now. It's a mix between a build system, a compiler. I won't go that route, it's not my forte. But one of the powerful things is that it has a set of rules that you can expand on, effectively writing small Python programs. And those rules are then treated as first-party citizen of the entire release pipeline. So what you do is, in the same language that you say, run this test suite, you also say, and run these security scans. Then you just run to the standard deployment pipeline or testing pipeline or what have you, and the security scans and security tests happen. Okay, did this work? Let me give you numbers. Well, we identified about 1,500 critical and high severity bugs. To give you a terms of comparison, because otherwise the numbers don't mean anything, the rest of the world combined in 2016 applied for about 1,000 rewards. The Vulnerability Reward Program, I highly encourage you all to participate. It is a program where we pay money, effectively, or rewards, which happens to be, for the vast majority, money, to security researchers that report us back security issues. So it's us, as in the infrastructure of security automation against the rest of the world. They did about 1,000 in 2016. We didn't compete head-to-head yet, but we're doing that this year. We're doing okay, but I think it's a nice step for the machine. We'll see how that looks like at the end of the year. Okay, time for a summary. Please wake up if you've been sleeping so far. This is where I give you the 2 slides that you have to take home. And hopefully we'll have time for a few questions afterwards. So, First thing, if you want to have a security strategy, a security testing strategy, you have to go to the security team and ask them to involve you into this work. Unless you can clone security engineers. If you can clone security engineers, then clone security engineers, which sounds fair. But if you can't, then make sure that security and testing and development work together. Second point, don't try to do too much at once. Focus on very achievable targets and go very deep, not wide. One of the promises, one of the siren songs of security is that you deploy one tool and will find 20 types of bugs and everything will be amazing. That doesn't happen at scale. It might happen in a very small company, but surely not in any sizable company. Pick 1, 2, 3 classes of bugs that have been plaguing you, and just go as deep as you technically can until you eradicate that, until you figure out how you're going to tell the developers, until you figure out how they're going to fix it, how the whole strategy looks like. Then move to the next bug. That has been the single largest finding that I get. And remember, false positives. No false positive, ever. Security is not the Grinch. The vast majority of the stuff that we do is just basic testing. We just happen to be finding security bugs that are a different type of bugs. That's a bug in an elevator. It just so happens that it asks for a password, but it's just a bug. Nothing special in there. Thank you very much for attending. And
for questions, please, hand up.
Hi, thank you for the presentation. I'm asking about a book to start with the security.
I can think of The Art of Security Testing and of software testing. Software security testing.
Art of security testing.
Software security testing, yes. I might be mistranslating, but I'll follow up on that. I have to say, though, that I would horribly fail the test where you ask the doctor how many books have you read about medicine and he says nothing. I would probably answer close to nothing on security. So shame on me for that. On my defense, when I started, there weren't many books, so there is that.
What does Mango proxy is with some open source?
So the question is, what's Mango? No, it's not open source, I should say yet. It's a tool that we built internally. As I said, it's tricky for me to talk about specifics. But in reality, it's just a bunch of Java code that sits on top of an HTTP proxy. No rocket science in there. Identifying HTTP calls is easy. I see. There you go.
Hello, thank you for your speech. It's interesting, how fast does your team react on new features that Google writes every day? How fast do you cover new functionality with security tests?
Thank you for attending. I think it depends. So in general, I guess the reaction speed for the security testing is the same that you have for security, right? So the base predicament that I have here is that security testing should be part of your standard security testing pipeline, sorry. So if you run your test for each CL, then you should probably run your security test for each CL. In practice, we're not aligned to the unit test schedule. We usually align to the integration level. So some teams do that once every few hours. Some teams do that daily. It depends on the specifics of the team. But it's fairly frequent. The side effect of that answer is how fast do you add new security bugs detection, sorry, when a new security issue is public. That happens very rarely, and it takes a lot of time because we need to go very, very deep. So it takes usually weeks for us to be able to ship a new class of security bugs, but they're not that frequent. So I think there is one over there.
Thanks for the talk. And my question is: suppose you aim for something like Heartbleed, so some kind of attack that triggers when you put wrong data into your system. So how do you approach that? Provided you forbid false positives, right? True. It will crash if you stuff some garbage data.
So this question is slightly outside the specifics of my domain because you're thinking more about memory corruption attacks rather than web. these sort of bugs is a lot more frequent in memory corruption. So this is where binaries come into play rather than a web platform. I think it depends. A bug as a heartbleed, I'm not quite sure it could have been found through automation, even though there are disagreeing opinions about this, about how much fuzzing, which is the common word we use for throwing garbage at a software in security. I think some of these bugs you're stuck with having to do manual analysis, but a large percentage you can find through automated testing. So binary fuzzing is the keyword for that. Now, how do you split false positives? So how you do distinguish a promising crash from a not so promising crash? Again, I think there is a set of heuristics that you can apply, and some heuristics are very effective and are highly indicative of an exploitable bug. To me, if we stay within the paradigm that all security bugs are just bugs, then that means that if there is a crash, you should probably fix it regardless. And so maybe that type of analysis is not super useful in your prioritization. But I see your point. It's definitely still an open problem in that space. I don't know if we still, perfect.
Well, what about SQL injection? I mean, do you automate it, or can it be automated? Are there any, say, best practices that do this and get it?
So I am lucky because at Google we don't use that much SQL, so that's not a problem we had to face that much. This said, I'm confident that you can get to a point where you have a high degree of trust in the detection of SQL injection, especially if you start having side channels. So if rather than relying, for instance, on the type of error messaging that you get, you rely on having the server reach out and do DNS resolution or other things. Now, there are a number of techniques that drive the number of false positives down. They come at a high cost in terms of false negatives. SQL injection, to a degree like XSRF, is one of these bugs that I believe is better tackled by hardening the framework rather than going bug hunting. But SQL injection is one of the hard ones. All the injections, to be honest, common injections is kind of another type, are very hard to automate. But there is a chunk of things that you can automate very reliably, especially if you can use side channels. So not just rely on the error messages that you get back, but actually forcing DNS resolution or pings or other things to happen through your SQL injection. And I apologize for the people that don't know SQL injection. It would take way longer than I have available to explain what it is and walk you through the steps. But thanks for the question.
Hello, thanks for the talk. I have another question. You're talking about security testing during integration tests or unit tests. And what about static analysis, like analyzing the code? I understand that you cannot reliably do audits manually, but there are some automated tools. Again, there is a problem of false positives because current static analysis is, well, complicated. But do you employ it some way?
I think you kind of answered it yourself, right? There is the problem of false positive. So yes, we do use it in very, very specific case. I understand that there are at least two groups that are very, very focused. Again, they go hunting for one specific instance where they have very high degree of confidence. Some other groups use it as a support to exploratory testing that I have learned in the previous talk is very important, apparently. So we do make some use of it, but I would say that compared to other realities that I've seen that have a lot of trust in static analysis of code, we don't use it that much. There is also the problem that there are many tools that can grok our database, our code base, right? If you have 89 terabytes and your tool relies on building a mapping memory of the entire code base, it's probably not going to work that much. But yeah, it's a good point. I have high hopes for static and dynamic analysis and symbolic execution in particular for the future. I think there is a lot of good things to be done in that space.